Ox Alpha, the model that's been going viral recently, is GLM-5.3-Flash. It's an extremely good AI model, and it's also fully run on Chinese AI chips, the inference. I believe the training is not. So I'm gonna tell you more about all of this. It's comparable to GPT 5.6 Terra and Opus 4.8. I think it's a very good model because these two models are also very good. So everybody has been using it recently, me included, and people have predicted, looking at the agent traces and the way it generates tokens, that it is GLM 5 point something, 5.x. Currently, intelligence versus cost is extremely good deal here. So it's even better than GPT 5.6 Luna Max, which is maybe which was previously the best intelligence versus cost model. And this is cost per task, which is what matters. So this is discounted. Now, Luna is also discounted. I believe that when you buy subscription from OpenAI, it's heavily subsidized. So this is also subsidized by the company. Now, the real costs, I don't know exactly like who's losing more money, but it's impressive that just a few weeks after we get Luna, we have even better model that has around the same cost but performs better. So this will force Anthropic and OpenAI to reduce their costs even further, depending on how long this is subsidized, how long this is discounted. Now, Anthropic has a different strategy. I feel like Anthropic does have premium models that are better, but they also need to improve their inference. I feel like this is going to force everybody to bring their costs down, including Anthropic and everybody. So this model really is on par with Claude Opus 4.8, but it's significantly cheaper. It's as cheap as Luna. So this is insane that only 3 months after we have models that are 25 or 30 times cheaper. So costs goes down 30 times in 3 months, which is insane. If you want to learn to build LLMs like this one from scratch, you can join my school to become AI researcher. We do LLMs, experiments, research, everything they do at Anthropic and OpenAI. I teach you how to do it here. So this model is designed to be very cheap for inference. So even though the number of parameters is similar to GLM 4.5, this 5.3 Flash has almost half the active parameters, and the number of layers is almost half. So it's active parts are a lot fewer. In the architecture, we have manifold constrained hyperconnections, which are invented by DeepSeek, as many of the Chinese labs, probably all other labs, have a lot of the technologies that are invented by DeepSeek. And then linear attention, this is most likely from MIT, but we'll see which linear attention and which sparse attention they are using. Other than that, MOE, MTP, LM, those are same as every other LLM. And what's most important is that it's multimodal. So right now it can look at the website it generates and fix errors. And vision is extremely important for this, especially for UI design and interfaces. And game design, 3D objects, and all this stuff. This is one of the biggest feedback that Zhipu or Z.ai team got from GLM 5.3. It's to add in vision. So they added it. And you see here how, because they are using this sparse attention and linear attention, you see how a lot less compute is necessary. The compute is not growing quadratically. It's growing a lot slower. As the sequence length increases. So that's why it can have million token sequence length. And it's even 3 times more efficient than GLM 5.3. So it's designed for ultra low cost inference. And this is why it can also be inferenced on Chinese AI chips, because for training you need more complex chips. But inference usually can be supported by many different chips. So for training you use NVIDIA, for inference you can use so many more. So linear attention is going to capture local dependencies, so nearby tokens, and usually it's fixed size. While sparse attention it's for the entire context window. It's for retrieving far away information. It grows as context window grows. Now, depending on the implementation, it can grow not so fast. For example, here the growth is slower. Usually this is how these Flash models operate. They sacrifice a bit of performance for a lot of inference speed, cost, and all this. And here there is lightweight indexer, which is part of this sparse attention, that's basically going to pick which parts from entire context you need, for which are relevant to predicting the next token. So that's why it's sparse. It doesn't look at the entire context window. It just indexes and then checks quickly which parts it needs, and then does attention just with those parts. I also saw this for the first time in DeepSeek architecture, but I'm not 100% sure who invented it. And they also invent this index pool, which compresses 4 indexer keys. So this is the lightweight indexer that's gonna pick which parts attention needs to be computed. And so index pool is gonna compress 4 of these indexer key vectors into one through weighted pooling, which just means you take 4 vectors and then you multiply each with some weight between 0 and 1. Depending on how important each of these 4 are, you multiply with some number between 0 and 1, and then you add them. So now this number, it makes sense to me that this number is learned. And then some small neural network or something is looking at these 4 keys and then deciding how important each one is. And these are all of the techniques to produce more intelligence for less compute, lower cost. And I'm really happy to see how cheap they can get intelligence down. So this is Opus 4.8 getting 30 times cheaper. And with now Astra by GPT, Astra also going to come out soon, the progress in AI is extremely quick. And I'm going off the path of the rails right now here, but I feel like Astra is a model that's going to be able to do automated AI research. But we'll see about that. And we can see here that it's using Kimi delta attention by Moonshot. So those are linear attention layers interleaved with NOPE, sparse, multi-head latent attention layers, which is from DeepSeek. You can see here how linear attention layers, they compress token information into fixed size state. So it doesn't grow as the context window grows. So it's just gonna compress. So it's similar to recurrent neural networks, but it's a better mechanism of compressing into fixed size state. So there are many videos explaining DeepSeek sparse attention. Basically, you take all of the tokens and then you maybe do some processing. For example, you divide into chunks. You can attend across chunks. You can select which groups of tokens are important, just attend over them. There are other few things to do in DeepSeek sparse attention. So I also made a video about it. So you see, for example, difference between gated delta net, which is very popular linear attention, and KDA is that for forgetting vector, for forgetting mechanism. Gated delta net is using one scalar for the whole matrix, for the whole state matrix that keeps the context of the previous tokens. And KDA, Kimi here, is using a vector, so each channel decays on its own. Each channel has its own decaying number. Here we can see how it can actually look at what it's doing because it has vision. Shui Xing. I don't know, maybe. If you know Chinese, tell me if I read this properly. Anyways, let's see. So it can. This is the main feedback that they got. So they need to add the vision to the model, which they did, so the model can look at the stuff it generates and then fix it. And here on VLLM recipes, we can see that it takes around almost 400 gigabytes. in FP8 or 772 gigabytes in BF16. So in VLLM recipes, we can see more technical information, which is where I got information about the architecture. And then they say they are doing inference on Chinese AI chips in full. So they didn't say which exactly Chinese AI chip, but so they say it's a large cluster and supported by high bandwidth interconnect. So, and from other information they talked about, it's most likely Huawei Ascend chips. So, so inference is easier and it can be done on many different chips. And even though single Huawei chip is not as good as NVIDIA's for inference or for training, for inference, they can just stack a lot of chips. So you can use, I don't know, maybe 8 chips to replace one NVIDIA chips, and it's okay for inference. And they have these high bandwidth interconnections to support these clusters. Also, Huawei chips use a lot more electricity than NVIDIA chips, but China has a lot of electricity, so there's not gonna be a problem there. And so they built a custom serving engine on top of SGLang, which is the famous, everybody's using this. And they used their GLM-5.3 powered infrastructure agent to help them. So we are now on the exponential curve where AI is starting to be able to improve AI. And I feel we are already like on the slope, right there on the slope, where this is GPT Astra, like literally on the slope right there. And maybe in like, I don't know, 2-3 years, it's gonna go, okay? And then these other models are a little bit behind. So this is all of the serving optimization techniques they used. These techniques are good serving. So in serving inference, I feel like the most speed up you can get with speculative decoding. And then all of these optimizations, they can get like, 20% speed up, 30% speed up at maximum. But speculative decoding is the thing that gets you like 5x or even 3x or 2x. And here they say that with all of these optimizations, they can reach mainstream NVIDIA GPUs in cost versus performance. So they mention these things about chips, they mention other things about chips here, but this is the main thing they are saying. I think when it comes to chips serving, is gonna be done on Chinese chips that can be done quickly. Now training is more difficult because my friends from who do this in Beijing, in China, they say that training on Huawei chips is difficult. There are instabilities, there are some random things happening, so NVIDIA is more stable. When you train, like you set the training is gonna do what it's supposed to do. But in, for example, Huawei, it sometimes has some instabilities, random things, loss spikes. So inference is easier, training is more difficult. This is why companies are going to train on NVIDIA, keep training on NVIDIA chips. This is why Moonshot AI had to pause their subscriptions because they don't have enough chips, but they're going to now get these Chinese chips for inference in maybe a month or two, and then they will just keep training on NVIDIA chips and use Chinese chips for inference. You can join school to learn how to code, build, and train LLMs like this from scratch. So there are so many people here, you can see. I'm gonna leave all of this below the video so you can become AI researcher in the group, and see you in the next video.